Välkomna till Arkitekturdagarna som arrangeras av Sveriges arkitekter på Formdesign Center i Malmö. Mitt namn är Gunilla Kronvall och jag är verksamhetsledare för denna plattform för arkitekturdiskussion både lokalt och nationellt. Hållbarhet är en utmaning som vi alla behöver förhålla oss till och arbeta med på olika sätt. Från KADK i Köpenhamn har vi idag med oss 2 talare som ger oss varsitt bidrag och perspektiv på just hållbarhet och arkitektur. Welcome to the Swedish Architecture Days and to a session with 2 talks from KADK, the Royal Art Academy in Copenhagen, on the topic of new sustainabilities, new specificities. And these 2 speakers will speak consecutively. So first we will listen to David Garcia, and he will then hand over to Paul Nicholas. Welcome, David and Paul.
Thank you. Thanks for the invitation. I suppose the slides are running. I only see my face right now. But maybe we can just get them running. Yes. So thanks for being here, being present today, and thanks for the invitation. Paul and I kind of decided on the title of Sustainabilities and New Specificities because of the things and aspects and intentions that we share. In my case, as an associate professor and master director of a master program called Architecture and Extreme Environment, those 2 adjectives in a way define much of the research and approach to teaching, specifically methodologies dealing with design in present world challenges. One of the things that we experience today is a new Anthropocene. We have a new way of having populated the world, and we've created this kind of exoskeleton around the Earth, which has made us permeate the globe with a layer on its own right. So this is literally an image of the world without Earth, just the infrastructure, the cities that so far we've created. Now that allows us for huge efficiency and communication potential and the economic geopolitical construct that we have today. But at the same time, it also means that it gives us a false sense sometimes of security. We have spread ourselves quite thin across the world, and where there's radical changes, those are felt much more profusely. And this is very clear in some of the disasters we've experienced. Tsunamis are nothing new to the history of the world, but they are new in how they impact the way that we populate the world when we spread ourselves so thin. And that's where specificities, I think, for us kick in as designers in the built environment. And in the next slide, you see a very relevant stone, which has populated the western coast of Japan for quite a few centuries. And as you can read the translation, it literally reminds people not to inhabit below this point because of the fear of tsunamis. And it's interesting because this populates exactly the same coast that was destroyed so heavily through the Tohoku tsunami in 2011, which is a reflection on the fact that a consciousness on the context at all levels, in this case with regards to natural catastrophes that were recurring, it's also being pushed aside by very often a kind of prowess and engineering egocentricity in a way that allows us or gives us a false sense of security, thinking that a higher wall, a heavier world that we can calculate ourselves to is going to be the solution. This is literally the present new solution. They had a wall in the western coast, which was about a couple of meters after the Tohoku tsunami. And the condition that everybody experiences now is this 12-meter wall. And this positivistic approach to knee-jerk solutions, instead of looking at holistic approaches of maybe we shouldn't populate so close to the coast, is something that we at the program really want to reflect upon and reassess the role of how architects approach specificity, in this case, site specificity. On that note, what we do in this program, and you will be seeing quite a bit of work of students and methodologies that we do together with the student master program, is how to reassess how we act and engage with the world. And one of the activities is that we are present in many of these conditions. We take the students for at least a month in areas which are out of balance to try and make them reassess the way that we can approach a context as designers and move away from an artificial ecosystem, which is becoming more and more fragile and distant, with supporting the human aspects of quality of life, as well as considering how these new conditions, which have become of a very large scale now, have their consequences and also their negative. So the positive of high rise and concrete that you see in the city always has an impact somewhere else, very often far away from the developed world, impacting many other communities, both economically and socially. And this for us is a way of reflecting on the longer chain of supply of all the resources that we use in building. I'll go through a specific example of how some of these methods are approached. So the first thing that we do in the course is present a series of parameters that go from health, demography, flora, fauna, history, culture, energy, infrastructure, industry, and sub-terms and parameters that the students research to try and know as much as possible and understand that many of these aspects are correlated to each other, that they create a holistic understanding or an ecology of factors. Instead of thinking this is the climate and this is the impact that tourism has in these localities, there's always a series of connectivities that become much more aware when the students are encouraged to collect all these facts and create their own visual encyclopedia that they use to try identify areas of concern. And this kind of tool allows a approach to designing or even visiting the site in context. I think what's become very apparent through these studies has been that it allows also a collective body of knowledge to be shared across them. And then they identify in a way challenges that have to do with the built environment, how those could be tackled. And I'm going to just give you an example of something that is very close to the necessity of being specific and the necessity of also finding new solutions. Parallel to this, obviously, we engage with the Sustainable Development Goals, which are a great kind of global umbrella to understand some intentions, global intentions and aims that we have as a global community. So we're going to look at a project that dealt with mosquitoes, and which I call the mosquito net disaster. Several years ago, we went with students to the Amazon, and we had a student who was interested in the problematic of malaria. And she took it upon herself to study the vector, that is the mosquito that carries the malaria virus, and how you could shelter or shield yourself from that. Especially given the fact that, and very relevant given today's pandemic, malaria alone kills over 2 million people every single year across the world, especially in some climatic zones, but that is the death toll of this virus. There's been many initiatives, we'll talk about those in a second, but her project was about testing how mesh material could both give a level of comfort and allow for the protection of malaria mosquitoes, because the problem is that netting has the drawback that you might think that air goes through a net, but it actually hardly does. So she studied the implications and measured the different nettings and different meshes and tried to evaluate which ones allowed for some kind of breeze to go through and some type of environmental comfort. Because what she had discovered in her research is that the nets that are now given, for example, by the Gate Foundations, which it's literally a venture that has happened now for several years. There are now in the order of 22 million nets that have been given to regions highly impacted by the malaria virus, have some drawbacks. This is what's called a long-lasting insecticidal net, or LLIN. LLINs are impregnated with an insecticide, and they're very robust. They're a very tight mesh. And those are the nets that have been donated to communities across the world in the millions. The problem is, if you try to sleep in one of these nets, you almost literally suffocate to death and almost overheat immediately. Here we have an example of a house that is very well ventilated, which is very comfortable to sleep. But if you want to protect yourself from mosquitoes, suddenly these nets make it almost impossible to sleep. So what happens is that people in the end don't end up using them. On the other hand, they end up using them as fishing nets. They're very tough, very robust, and they've been used now across lakes and rivers thoroughly through the tropics, with the side effect that the insecticide is literally killing all the biocomplexity and their literally livelihood of fish. For me, this is a great example of how not looking into the consequences and the implications of something that seems very obvious, but detached from the culture or even the proper experience of trying to sleep in those nets for months at the high season is a way of misguiding a design approach that has no specificity thoroughly embedded in its design strategy. On the other hand, we have a colleague at KADK, Jakob Knudsen, who now leads a school, who tried to look at this problem from an architectural perspective. And he tried to see that perhaps the way that where we inhabit and where we sleep, looking at how mosquitoes normally navigate at a maximum of 2 meter height above the ground, and then making housing which was above 2 meters, so sleeping quarters were high up, allowed to suddenly look at architecture specifically and from a kind of much more curated approach to the problem, and allowing for both ventilation and the dynamics of the mosquito to be part of the design of the built environment. So this is, in a way, a clear example of the necessity to very closely curate the challenges at hand and how they're interconnected to many other aspects, from technical to biological to social and cultural. And unless that is done, then many of the gestures, it doesn't matter how well intended they might be, they are detached from the real impact that they might have. And this obviously plays a very good role, important role in also looking at building sustainably in the world. Also quite important in that process is looking at what are the challenges. So we teach our students and researchers and collaborators a root cause analysis process that literally carries on the question and the problem throughout a series of specific sets of questions, and on that note starts to identify the origin of the real problem and creates a network of solutions that are intertwined and problems that are intertwined to better target how that might be solved through design strategy. So dare to innovate is one of the most important aspects when we want to react and create some change. We feel that experimentation is crucial. Experimentation in artistic practice and in science are the keys to be able to kind of push the envelope further. And we're going to look closely at a project that deals with Alaska, which was one of the years of our study, which has a very interesting set of factors. Amongst many things, and 95% of the materials used in construction in that state, which is larger than Texas, is imported, albeit having huge forests around in its landscape. Students try to create beams that could be frozen. This is a very efficient way of charting the forces of a beam, and could they then be done with wet lattices or cord that then is frozen, and what would be the loads as a way of making beams efficient, or at least specifically linked to the climate of a season. Now I'm going to show a video of a student project that deals with the challenges of creating material for insulation in Alaska. So maybe if we can play this video. resource that constantly precipitates the ground from pine trees. And the way that he tried to test this was both scientifically in measuring the temperature and insulation values compared to other materials, but also, I would say, as a personal experience, as a embodied reaction to his own insulation exercise. And we can see here how he literally created a suit that he was wearing as an intention to also communicate his project to a broader public that he might be meeting. And the results were quite interesting, both in how effective pine needle insulation was, but also in how he was able to communicate by using a wearable structure instead of just a box that might just test the material, the efficiency of his experimentation. If we can just move on the slides. Another project which is interesting, if we could just jump over the video, yeah. Is one of the challenges that we met in the Gobi Desert, one of the biggest deserts in the world, in one of the regions that builds most in the world. So China has in the past 10 years built as much or used as much concrete as the US in the past 100 years, but they actually are importing about 80% of all the sand used to build. And that is because the sand from the desert is often very fine, very rounded, and cannot bind to concrete. So the sand as a resource has become a silent crisis, which all building sectors are very aware of. And one of our students started to ask themselves, well, aren't there any other way of binding sand that could be used? And she discovered that sandstone, by working with geologists, is actually bound by bacteria. Through the pressure of the sea, through many hundreds of years, and the bacteria that has been around these sand corns, as it dies, it binds the sand corns together. So her experiment was, can this be then used also in a desert? Can we then bring bacteria with us, which is innocuous to human beings, and start to use what's otherwise a huge resource, but not capitalized upon? And her results were quite interesting, where she started to make bricks and test their resilience with regards to this new type of approach to a materiality. But just as important are the social impacts that many of these gestures can have when you start to understand communities that have and live under very different conditions. So if we could play the next video, which was from our project in the Atacama this year. And I think the video is quite self-explanatory. And we could put up a bit of the volume up in this case. Raise the volume.
We call a campamento when there are 8 or more houses. They don't have the legal property, and also they don't have at least access to one basic service, like electricity, sanitation, or water. According to our studies, 10 families go to a campamento each day in Chile. This incredible rise of people going to campamentos is because of public politics and the high price of the ground and the houses. Each year we ask communities about their concerns. In January maybe they don't have access to water. For example, in Mejillones they don't have access to the public supply, so they have water tanks which are filled by water trucks, and the price of the water is really high, much higher than in the formal city. The connections of water and electricity don't have the knowledge, and so we have different problems. The pipes get broken, the electricity system collapses many times.
So as we can see here, the fact that the challenge was met by an acute sense of the local potential, the fact that there was a lot of salt water and there was also a lot of sun, allowed the student to try and test a new way of introducing light, but also clean water to a community. And here the sense of collaboration with the community was obviously key. It's amazing that somebody who has so little, a family, offers their roof and sacrifices their roof for a student to do an experiment, which is actually quite telling often of communities which have very little, how willing they are to participate and engage with somebody that wants to try and find an alternative to some of the challenges that they might be meeting. So in his construct, Henry was not only just piping seawater that by the power of the sun was literally evaporating and created drinkable water that they could tap from this kind of lamp, but he was also using the salt to create electricity, in essence, literally as a battery, a salt battery that gave light during the evening. The interesting reflection on the family was they were about to just buy some huge fluorescent lights because they just needed light in that area of the house. And suddenly this alternative kind of gave them a way of understanding other possibilities. But even more powerful was that when talking to this gentleman that sacrificed his house, he said, well, what's interesting for me is not so much that this solution works, but that actually it's allowing me to think that I can also just do experiments. And I think that's the idea of empowering our students with the possibility of creating new solutions is one of the intentions of the program. And I think it's one of the intentions that, or elements that architects should have and recall back as a natural process of design. But at the same time, it's a very important aspect also when you meet other communities and to understand that a lot of change can also come from the community themselves. This project, for me, it kind of represents clearly how it is linked to both the necessity of being very site-specific and how sustainabilities can be redefined by using experimentation in architecture to try new alternatives. So I'm going to end the lecture here, albeit I had another example of how that transformed into architecture, but I think this is enough to try and communicate how sustainabilities and specificities are used both in our research approach and with the student teaching strategies to reassess how we design in the world today. Thank you. I'll leave the floor now to Paul.
Hello, my name is Paul Nicholas. I am an associate professor at KADK. I'm part of a research center here called CITA, the Center for IT and Architecture. And I'm also the program responsible for a candidate program here at the school called Computation in Architecture. The specificities and sustainabilities that I would like to talk about in the second half of the talk are to do with technologies and materials. And they emerge, I think, from the perspective of our research work with computation, with CITA, and also across the work developed by students at our teaching program. If you could put my presentation up onto the screen. Great. Okay, thank you. So the starting point for this talk is just perhaps to introduce the research center, CITA. We have about 16 people at the moment across PhD, postdoc, and full-time research staff. And I suppose our remit or our base understanding is to think about the impact of technologies on architecture, not as kind of an add-on or as something that you grab off the shelf to optimize an existing practice, but in a more fundamental way, as things that we might use to fundamentally rethink the way that we practice architecture, that we design, that we fabricate, that we assemble and construct. We have a number of particular areas of research interest at the moment. The first of these is digital fabrication and robotics, the way that robots are changing the information flow between design, software, and fabrication processes. We are also interested in new material processes, so the ways that new design and modeling methodologies, the way that new simulation methodologies lead us to new understandings around material, its behavior, and new deployments of those materials. And then a third field of particular interest at the moment is in machine learning and big data, and the new models and methods of practice that we see emerging around those modeling tools and around the possibilities for gathering architectural information from the real world, from the design world, and using that to further particular design concerns. So as I said before, these are core research areas for CITA. They're also research areas for our master's students who work with those same technologies, with those same research interests across their projects. I think the insight that we begin with is that actually architecture stands on the edge of a new era in which we are beginning to have advanced design, advanced imaging, advanced sensing tools that are becoming coupled with large databases of understanding about performance, and the capabilities of prediction and computation. And that this connection is allowing us to capture quite specific levels of material understanding, understandings about material performance, about material behavior that have previously been out of reach. And the interesting thing about this is that it allows us to start to think very differently about what a material is, about what our relationship is to material as architects, and how we can start to, on the basis of that new relationship, start to employ and deploy materials in new ways. So we find also that perhaps at the moment, we are at a moment where material is becoming increasingly central to our architectural practice, to challenges of sustainability that we are facing at the moment. At the very largest scale, we're simply using too much material at the moment. Just a few weeks ago, we passed the day on which we had used 1 Earth year's worth of materials, and we are now into the material resource of a second Earth. I suppose more specifically for construction, we have a similar kind of challenge where we have focused on our materials around a particular set of materials, a limited set of materials, maybe the materials of modernism, we might call them, which are the focus of nearly, of the vast majority of our construction practice. And these materials, some of them, we are finding ourselves drowning in, and then others, as David pointed to in his talk, we are actually finding increasingly hard to source, increasingly expensive. And these are many of the base aggregates that we are familiar with in construction to make glass, to make concrete, are becoming harder to find, harder to source. So how should we be thinking about this at the Academy? I think David before pointed to the UN Sustainability goals. These are central to the way that we are directing our research, also our teaching, and particularly around SDG 12, which has, I think, this sort of central question about how might we build smarter with less? How might we, from an academic perspective, or I suppose the perspective of the Academy, how might we think and prototype new material practices that use technology to enable new systems of materialization, new ways of going into architectural material practice that are hyper-optimized, that are renewable, and that are recyclable. What I'd like to do in this next part of the talk is to show you 3 glimpses of what those practices might be. Each one takes a different perspective on that challenge. The first is perhaps the idea of maximum performance and minimum material use. Across several projects, if you could play this video, please. We have been working with robotic forming technologies and exploring the way that they allow us to take optimized designs, highly optimized designs directly from a computer to fabrication, to fabricated panels, and do so in a way that is very cheap and very fast and very effective. So bypassing the traditional needs of mold making that you would find when you stamp parts or use more traditional metal making processes. So these are particularly interesting because we can link those new fabrication abilities to the ability to think about structures that might be extremely thin. We have been working with bridges, with arch structures that are only 0.5 millimeter thick and which span 4, 5, 6 meters and can carry the weight of a person walking across them. So materials that where we are trying to get the absolute maximum of performance from them on the basis of design computation, which you see here, the computer searching for good designs, finding designs that are good for both structural but also walkability perspectives, architectural perspectives, and linking those to new emerging modes of fabrication that allow us to actually make these kinds of structures. Here you see some of the simulation work that goes into those. And then a process of also prototyping and testing that we engage with from a research perspective against different kinds of architectural structure, different kinds of base metal, new metals, recycled metals, trying to understand the full architectural palette of possibilities there. The second perspective is the idea of minimizing waste. So here we work with timber. This is a recent project called Rawlam, where we begin with the idea that we might be able to use more of a log. So currently in many parts of the timber industry, it is very normal that logs are CAT scanned before they go through a timber mill. And a huge amount of data about the internal structure of that log is recorded and understood. Here you see a CAT scan through a timber element. Now, all of that information is thrown out the minute the log leaves the factory. At least it is not accessible to architects. And so the question we ask in this project is, if we did have that information, if we did know about the full performance of a log, could we actually start to design in ways that allowed us to use as much of that material as possible? Not just the best bits, but also the bits that are not so good, the knotty bits, the barky bits, the bits where there are structural failures. If we were able to position those different parts of the timber in different places, we would be able to save a lot of the offcuts, a lot of the processing that occurs in the timber industry, where you can have up to 70% of the log being lost through cutting. So here you see a series of models that link a database based on CAT scan information of timber to a design approach which sorts, classifies and positions the different parts of that timber log in the appropriate parts of the designed structure. And then lastly, some of the details there at the end. I mean, the interesting thing here as well is that the ability to use more varied parts of a timber also, it does not just have economic or performative implications, but it also leads to interesting possibilities in terms of the aesthetic of timber architecture, as well as the detailing and the construction of elements of it. Those are projects which are perhaps represent ongoing strains of ongoing trajectories of research for us, but we also have new emerging questions. And I think at the forefront of those is this suspicion, maybe, that perhaps it may not be enough just to use less material more effectively. We might not be able to optimize ourselves out of this challenge. It might not be enough just to use less material. Perhaps what architecture is facing over the next 10, 20 years is a more radical shift in our material practices. And that shift is specifically the shift to biomaterials, to the biosphere, and moving from a condition of resource scarcity that we have in the geosphere, materials which are beginning to run out, to a condition of material abundance, which is what we see in the biosphere. And so what we are starting to do here is to try to think about, well, what are the material systems? What are the fabrication systems? What are the design modeling interfaces that let us start to engage these untraditional materials within architecture? And we have a series of projects across national, also EU scales, which start to investigate these questions across a range of different biomaterials. So to provide just a very short glimpse of those, the first project, Predicting Response, is a project that we are undertaking in collaboration with DTU Chemical Science, looks at the use of new machine learning tools as a way to be able to create predictive models for unpredictable materials. One of the issues with biomaterials is that we do not have the long experience with these materials that we have with concrete, steel, glass, and they are also not as standardized and not as engineered as those materials. So that the core of this project is about finding ways of predicting their behavior so that we can begin to simulate them and work together with them to fabricate, in that case, interior and exterior architectural elements. A second project, also just beginning, is called Fungal Architectures. And this is a project that explores the use of living mycelia within architectural elements. So you might be quite familiar with seeing chairs, furniture pieces, wall cladding elements that are made out of mycelium, which is a fungus. It's a particularly interesting material. But in those conditions, it is always killed before it is brought into an architectural perspective. What we are interested in is working with the living material and to understand how that might not just be an acoustic panel or might be a piece of structure, but might actually be functionalized to take on a whole host of other architectural performances. So could your wall send messages, for example? Can you pass simple computations through a material substrate? And we know that we have found that you can. And part of the project there is also about understanding and prototyping architectural elements that leverage that capability. Perhaps the last slide that I will finish on here is just the larger question that we see opening up around perhaps these future material practices. And that is very much one of beginning to think again about particularly temporality within architecture, to think about our relationship to materials as one perhaps more of co-production rather than a fully top-down mode of working, and to think about how architectural design might not just be a one-off act, but might need to be something that also encompasses a longer time period of maintenance, of engagement between architects, their buildings and their materials. Thank you very much for your time. Thank you.
Thank you, Paul and David. Are you both, I don't know if David is also still there?
I am.
All right. For these, and time is running quickly, but I want to ask one question and that I posed to the two of you, if you could give brief comments. You're both in the university world, in the world of sort of theory and teaching. You identify and you innovate around these sustainability issues, of course. But how and when do these kind of innovations become part of the building industry, part of the practice of architecture, part of the practice of construction? On a larger scale, I mean, you mentioned prototyping, but when does it actually become part, do you think, and how, on a larger scale of our industry?
I mean, one direct answer is through nearly every research project that we are involved in includes industry partners, and there I think it is not a question of how the research becomes part of industry tomorrow. That is actually industry thinking 5 years ahead, 10 years ahead. How can they begin to prototype things so that they are able to integrate over a slightly longer time period? And we are working both with smaller fabricators, with companies producing concrete elements, building elements, also with architectural firms, also with engineering firms in all of those projects. And I think there, of course, I think the elements, the prototypes are important because they embody the ideas and they allow them to be communicated. They allow the value to be seen. But the real importance for industry is perhaps in the methods that lie behind them and in the thinking and the strategizing towards the future that occurs there.
Yeah, I mean, to add to that, there's, I think I can speak for both programs. There's a lot of the research that bleeds into practice through industrial PhDs, which is a very interesting way of designers and manufacturers to take ownership and stake and invest, which means that that's a real interest. And then there's a time frame, as Paul has mentioned. But another aspect is policy. And here, I think we've seen quite a big shift in not only our program, but other attitudes and initiatives that KDK has had with regards to sustainable approaches that create an impact policy at a political level that suddenly trickle down into requirements that suddenly industry and manufacturers immediately have to react, and suddenly they meet the top-down researcher, perhaps from our institution or another, who is developing exactly those solutions. And so suddenly you have a top-down trickle of some of the initiatives that we promote, and together very often with policy and politicians, make them aware of their relevance, and they suddenly understand that architecture and built environment needs to be aware and respond to that, creating some frameworks of legislation, and then both industry and research quickly going up and already starting to offer those possibilities. In essence, what happens is that there's a good reception at both levels, and I would say almost at all levels of what the architectural practice requires to be able to manifest itself.
Good. Thank you very much, the two of you. And with that, we conclude this session.